So you just saw a pretty cool video on how to develop the formula for the area of a trapezoid. I hope you took the time to think through that in that presentation, but it's basically the bottom line is this. You take the two parallel sides. Now, if it was a more than two parallel sides, it wouldn't matter which two you did, but in the iconic trapezoid, you take the two parallel side lengths, add them together, a plus b. Multiply that times the height. Remember, that was because we basically had a parallelogram once he flipped that trapezoid around and put them together. So you had two of the same trapezoids that formed a parallelogram. A plus b was the length of that entire parallelogram times the height. So that gave us the area of that parallelogram. But then half, because we only wanted one of the trapezoids, not both of them. So a plus b times h divided by 2. Which is our standard formula for the area of a trapezoid. Now, remember the whole deal that a square is a trapezoid, a rectangle is a trapezoid, a rhombus is a trapezoid, etc.? One of the mathematical reasons why we like that definition, that inclusive definition of trapezoid, is this formula works for all of those things. If a rectangle is a trapezoid, then we should be able to find the area using this formula. If the square is a trapezoid, we should be able to find the area using this formula, etc. And yes, we can. In fact, as you saw in the video, if that parallelogram was really the two trapezoids, we can find the area as if it was a parallelogram and then just take half of it. So let me take you through that really quickly. So first, we're going to look at the rectangle. So the area of the trapezoid, a plus b times the height divided by 2. So instead of the iconic trapezoid, imagine the rectangular trapezoid. The top parallel side is a, the bottom parallel side is b, although it wouldn't matter again, but I'm going to go with those two sides. But since this trapezoid is a rectangle, then the length a and the length b are the same length. So instead of a plus b, we could just say a plus a, because a and b are the same measurement, the same length. So we could say a plus a times the height divided by 2. Now just, I hope some simple algebra here. If you have a plus a, what you have is 2a. So you have h times 2a divided by 2. And since 2 divided by 2 is 1, sometimes we say the 2's cancel, but I like to say 2 divided by 2 is 1. So we have h times 1 times a. We just have a times h times a. So the area of a rectangle is just a times h, the base times the height. So there it is. That's what's nice from just a pure geeky mathematical perspective, is the area of a trapezoid, no matter if that trapezoid is rectangular or anything else, the area formula still applies. And that's a cool thing from a mathy perspective. Now what about the square? A square is a trapezoid because it's a quadrilateral, at least one pair of parallel sides. So we should be able to find the area of a square with that one formula. Let's see. So h times a plus b divided by 2, but since this is a square, a and b are the same length. Actually, all four are the same length because it's a square, but let's just focus on the two that matter in this formula. A plus b could be expressed as a plus a, since a and b are the same thing. A plus a is 2a. 2 divided by 2 is 1. So it's h times 1 times a, or just h times a, or a times h. But now, because this is a square, isn't h and a and this side and this side and this side, aren't all these measurements the same since this is a square? Yes. So h and a are the same. So a times h can be equivalently expressed as a times a, which is a squared. The area of a square is an a by a square. So the area is a times a to the second power. We say a squared. That's why. The reason we say a squared with a power of 2 is because it geometrically connects to the area of a square. A times a squared. So we start with the area of a trapezoid. We get to the traditional formula for the area of a square, a squared, the side length squared. Now we could go on and do this for all of them, but the point is this. By defining trapezoid the way we've defined trapezoid inclusively, then one single formula can be applied to all trapezoids. And that's a powerful thing. Can you imagine students learning about area? You don't have to learn the area of a rectangle and a square and a parallelogram and a rhombus and a trapezoid as all these different things. In fact, they're all the same thing. They're all trapezoids. So if you can learn one area formula, you've learned them all. Now, I also hope, then this, by the way, 6th grade standard, this is about a 6th grade standard. This is what would happen is that students would be encouraged to make sense of the area of a square is a squared, but it comes from that area of a trapezoid. The area of a rectangle is base times height, or a times h, but it all comes from the area of a trapezoid. So if we can develop the area of a trapezoid, we can develop the area formulas for all trapezoids, including square trapezoids, rectangular trapezoids, parallelogram trapezoids, etc.